This is the last video for Arduino, where we will learn the last input in the series. As we recall, in video 2E, we learned about the light sensor and flex sensor circuits. And in video 2F, we learned about the two digital input sensors, the button and the tilt sensor. Today, we are going to learn the last sensor, the temperature sensor. This is the overview of the video. First, we will introduce the working principle of a temperature sensor, followed by the circuit construction of temperature sensor circuits with serial monitor reading. Next, we will have the circuit construction of the temperature sensor circuits with various outputs. Lastly, I will have a summary of all the sensors and outputs, and as well as their functions, since this is the last video for Arduino. Temperature sensor is a sensor which senses a temperature change in the surrounding. One physical property in the sensor changes when there is a temperature change, and by measuring this change in the property, we can then draw a correlation to the change in temperature by using equations. There are 5 types of temperature sensors as listed, where they work on different physical properties. The first type is a thermistor, where the resistance changes with temperature. There are 2 types of thermistors, NTC and PTC. NTC stands for negative temperature coefficient, while PTC stands for positive temperature coefficient. Looking at the graph, the resistance of the NTC is inversely proportional to the temperature change, while PTC is directly proportional. The second type is called resistant temperature detector, RTD. It works similarly to the thermistor, as the resistance changes with temperature change. The difference is that the resistance of RTD increases linearly with temperature, while thermistor do not. Platinum is the most favored metal to be used for RTD due to its wide linear temperature range, but it is usually replaced with nickel or copper due to the high cost of platinum. The third type is known as a thermocouple, which is made of 2 different metals joined together to form 2 junctions. When the junctions are placed in 2 different temperatures, an EMF will be generated, which is dependent on the temperature gradient between the 2 junctions. When the temperature is the same, the EMF will be equal and opposite, and there will be a net zero current flow between the 2 metals. It is commonly used for applications where a huge temperature range is required. However, the correlation between the EMF and the temperature is nonlinear, and the temperature measured is not as accurate as compared to thermistor. The fourth type of the temperature sensor is known as a bimetallic strip, where it is made of 2 different metals bonded together. These metals expand at different rates when heated, and it can be used as a way to turn off a circuit when temperature exceeds a certain value. An example will be a fire alarm. The last and the most common type of temperature sensor is the liquid in glass thermometers that is used in a laboratory. The liquid in the thermometer expands when heated and rises up to a scale that is previously calibrated. From there, the temperature can be read. The most common liquids used are mercury and alcohol, with alcohol being more common due to its low toxicity as compared to mercury. Similar to any part of the sensors that we have talked about in previous video, remember to treat your sensor and your output as independent circuits. For the construction of the temperature sensor circuits with different outputs, These are all the components that you will need. One Arduino board, one breadboard, one bunch of jumper wires, one set of different outputs which includes one buzzer, one DC motor, one LED and a 330 ohm resistor, and a servo motor. Okay, in addition, we also need a USB cable as well as a temperature sensor. First, let's take a look at our temperature sensor. The temperature sensor has 3 legs, okay, and it has a curved side, okay, and a flat side over here. So, with the flat side facing you, okay, the far left leg is 5 volts, the middle leg is signal, and the far right leg is ground, okay. The emphasis of the polarity for the temperature sensor is very high, because if we connect the sensor the opposite way, the sensor will heat up to over 200 degrees Celsius and you will get hurt if you touch it. So always make sure that the flat side is facing you while you are connecting the circuit. Okay, with the flat side facing you, connect the first leg, okay, to your 5 volts. Second leg to A1. And your third leg to the ground. Last but not the least, power out our breadboard by connecting the plus sign and the negative sign to your ground and your 5 volts respectively. Let's upload our codes to Arduino and open the serial monitor. I'll open up the serial monitor. We will see the temperature that the sensor senses. Do note that the values that we see here are not the actual signals, but the signals have been converted from the raw signals to sensible values using the equations over here. Okay, so now let's try to change the 5 volts to the ground and vice versa, meaning to connect it in the wrong polarity, and we observe what happens to the serial monitor. Okay, so do note that we shall not touch our sensor for now because it will become very hot. Okay, if you observe, right, the temperature is now 200 plus degrees Celsius as we have connected the polarity wrongly. If you place your hand, okay, close to the sensor but not touching, okay, you will feel that the sensor is actually warm. Okay, so now let's change back to the correct polarity. Okay, you will see the value actually dropping because the sensor is now cooling down. Okay, if you see negative values on the serial monitor, okay, for instance like this, okay, it has to do with the sensor not connecting to the power 5 volts, as you can see over here. Okay, and okay, if you see that the temperature is over 400 degrees Celsius, okay, and this is because, it is because the ground is not connected, or the signal, okay, the signal is not connected. So you can see that if the signal is not connected, right, the temperature will just like fluctuate or like giving some random numbers. Okay, this is because the A1 now, okay, the A1 signal is not receiving any signals from the temperature sensor. Okay, and so okay, so now I'll put it back first.
So do not get alarmed when you see the 400 over degrees Celsius on the serial monitor, but do check that the circuit is connected correctly, okay, the polarity as well as the wires, okay. No wires are dangling and not connected to our sensor. Okay, so once we are sure that the circuit is correct, we can now use the temperature sensor to sense different objects, such as your body temperature, okay, or the room temperature for now. So it's like around 23 degrees Celsius, and my body temperature is around, it should be 37, but it'll take a while for it to heat up. So you can see that once I touch the sensor, the temperature should heat up, okay? And then once it reaches 36 or 37 degrees Celsius, it should actually stop. But it might take a long time for it to reach that. So we are not going to wait for so long, yeah?
After understanding our sensors, now let's continue to build our sensors. After understanding our sensors, now let's continue building our circuits with different outputs. For the different outputs, please refer to the various videos if you are unclear of the connection, as I have listed here. As this is the last video for Arduino, I'll make a small summary with regards to the inputs and outputs. So in general, these are all the inputs and outputs that we have went through for the past 7 videos. If we are going to build any circuits, okay, using any sensors and output, just remember that each part of the circuit is independent. Meaning, when I want a light sensor circuit, the circuit diagram will look like this, regardless of what or how many outputs that I choose. Okay, similar to all other sensors and outputs. The only thing that is connecting the different electronic components is the coding. For instance, if I were to use a light sensor, a sample code will look like this. The 3 boxes highlighted are the location where you put your codes for your output. An example will look like this. Okay, these lines that are inserted are instructions for the outputs, and they remain the same regardless of which sensor you are using. If we are using more than one output, we just need to copy and paste the same lines before and insert to the correct places. Do note that the lines must always fall inside the curly brackets.